Pickaxe Editor is a very simple program to use. Once you've installed and you open it, let's look at the layout. There is our new tab where we can start new text or basic documents. There's a new flowchart. When you click it, then it opens up your interface for your specific IC that you are going to be programming. Block is a sister program to this one, and you got open previous files. You can save this file, then you've got your copy, paste, snip and cut options over there. You've got print or convert to PDF. Then you've got your flowchart tools over here: select, grid, convert, group, line and zoom. We'll look at the convert just now. And there's the check for syntaxing, and then there's the program button. If you've got a pickaxe connected to the PC and you click that button, then it downloads the program onto the programmable IC. On the left over here, we've got the system settings. Firstly, what type of pickaxe am I working with? In order to look at that, all you do is you just look at the coding on your IC in real life, and you select the IC from the list that you've got over there. COM ports refers to how is the computer going to communicate with the IC. There you're just going to select which COM port. I've got no pickaxe program or pickaxe connected to my PC at the moment, so it says not available. There we've got simulation. It just says what IC are you using to simulate. If you change that type, then it automatically changes that in accordance. At the bottom over here, we've got the layout for the IC, and this is what we use to simulate the program. It shows us what's on, what's off, and we can actually adjust values and so forth. This section over here is my working surface. This is where I'm going to be drawing the flowchart, and on the right here are all my connectors or all my instructions. There we've got the start and the stop. That's the beginning and the end of the program. Symbols with parallelograms, symbols like that, refers to what's happening on the outputs. This will turn multiple outputs on or off. That will turn one output on, or that one will turn one output off, and that is for motor control systems. That symbol there is just a wait, in other words a short pause in the program which you program. Symbols like these are decision. They look at if a value is in a certain range or a certain level, then it does a specific task, and if not, then it does something else. So it's a typical if statement. A comment we can add next to a block to give us further detail on a specific task, and the basic adds a basic command. When we get to the variables, we are now looking at variable inputs. Again, we've got the compare like we had with the common, an expression. Symbols like these refers to the calculation and storage of data. So this uses the memory elements. Expression, perform variable mathematics. Increment, basically it adds one. Decrement takes one away. Random generates a random number between 0 and 255. Again, in and out, those control the inputs and the outputs, or it reads the inputs and the outputs. And there is a time function which we use to enable or disable time incrementing. These symbols from repeat down to loop, that is for a algorithm that we're going to place somewhere in a program. If we go down, time, read and write, again these are data elements. procedures. These are for sub-algorithms or sub-programs in your master program. It's basically start, stop or end the subroutine and then go back to the main program. There's an interrupt, enable interrupt and go to a sub procedure. Then we've got sound functions. You can see again those are all output based, and we've got the ability to play a tune, play internal ringtone, play a beep, or play from an iPod, or play an actual MP3 if we've got the correct hardware connected to our microcontroller. Firstly, let's look at our conditional statement. That's your decision over there and your analog over there. So I'm going to start off by just inserting a decision in there. Now when I double click on the decision, it opens this window, and this window basically says what is it going to do. It says, okay, if we have a 1 on C6, that's the condition that it's looking for. So let's add a comment there. So the comment there is comment look for 1 on C6. Okay, so now this comment's got nothing to do with the program, it's just there for us to see what's happening, and it says that the decision there is looking for a logic 1 on input C6. So now we say we want to turn the output high if it's true, and if it's false we want to turn another output high. So we need to now draw a line from the decision there to there. It automatically says the values there. If we open this, we can say B0 has to turn on, and for this one we say B1 turns on. So if we run the program and C6 turns on, then B0 is going to turn off or turn on. If not, then B1 is going to turn on. That is a simple decision. If I wanted to work other way around, I just select it and I click on this swap yes and no function, and then it will swap my decisions over there. Let's scroll down a little bit and we look at the analog input. So my analog input now is looking for B1, and it has to be between 66 or 100. I use those bars to slide up, and I can say, okay, if it is between 72 and 169, then it's considered yes. If not, then it is considered no. So I can now adjust these according to my wishes. And then if it's high, then it has to do this task. If it's low, then it has to do that task. Let's just link those two, and that is as simple as a decision aspect will work. It is important for most programs, especially programs that are constantly looking for inputs, to run through the same program or the same section of the program repeatedly. In other words, let's say that once this has been set to high, I want to go back and retest everything. Then we take this output back to between the start and the first decision. So now the program will run through. If that's a no, it'll go back and it'll repeat the process. This process is called looping. Let's add a loop over there again, and now we've got constant process of looping through in this fashion or in that fashion. Once the program is run through, this program doesn't know what to do right now, so I need to give it a task to complete or somewhere to go from there. So now this is an endless loop. No matter which state the inputs are going to be, it'll constantly run either through that branch or through that branch or through that branch, but there will be no change in or no end to this program. So what we can do is we can just say select there, delete the line. We say we want to place an end at the program there. So now if this decision says no and this decision says yes, then it'll run through and it'll stop at the end of the program. Let's quickly just say B1 has to go high. No, sorry, cancel. B2 has to go high there, and B3 has to go high there. Once we've done the program, we can click on the simulate button, and that now gives us the opportunity to run through the whole program, and we can now see what is going to happen in this program. So when I click run, I can change the speed at which the program runs, and this program is run through. Let's remove that one and add an endless loop for explanation purposes. So simulate, run. So we can now see that this entire loop keeps going. Now C6 was that decision. So if we activate C6, then it runs through that loop. If we deactivate C6 and we go to B1, B1 is an output. So we stop this. That has to be C0, which is an analog input. If we run the program and we go to C0, which is an analog input, we right click on it, we can now adjust the level at which the program is going to run through. If I pause quickly, that block over there represents that is the step which is being taken at that point in time. Now if I want to look at this in the programming language, then all I do is I go to home and I click on convert, and then it converts my entire document into my .bas file, and from there I can now look and see exactly what is happening in the program. Once I'm done, I can save and continue at a later stage, or I can upload to a programmable IC.